In this video, we're going to use algebra tiles to help us solve our problems. We're going to use the algebra tiles to help model the algebra problem, and then solve it using the algebra tiles, and then solve the algebra equation to help us find the solution. We have yellow square represents 1, red square represents -1. Then we have this aquamarine color, which is x, and that's a unknown length. We don't know how many yellow squares it would take, and your algebra tiles won't be exactly that, just represent any unknown. We also have the red rectangle that represents -x. We have a big square is x squared, and that's blue, and then red is -x squared. We're only going to use the +1, -1, and +x, -x. We will not use any of the big squares on this worksheet. So let's take a moment and look at our first problem. A student started with 4 candy bars in her bag. A friend dumped some more in the bag. The student now has 9 candy bars. How many did the friend dump in the bag? Take a moment and see if you can model what this would look like with the algebra tiles. We'll again be using our +1 or -1, +x or -x to represent. What do you think that's going to look like? We'll have some on the left and some on the right. Write that down, what you think that'll look like. Otherwise, it's going to look like this. We started with 4 candy bars. A friend then dumped some more in the bag, which we will call x. They now have, which is our equals, 9 candy bars. So our equation will look like this. The question always tells you what the variable is. It says, how many did the friend dump in the bag? That's our x, what we're trying to find. Whatever you're trying to find is always your x. We saw that they dumped some amount. We didn't know how much that was. So what am I trying to find? I'm trying to find how much this x is. We see that I have 4 on this side. I have 9 on this side. We can balance this out by finding just x. I can do that by taking away the 4 on the left, and if I take away 4 on the left to keep it balanced, I have to take away 4 on the right. So that would look like this. As you can see, I literally took these 4 and took them off of the scale. I did the same thing then with 4 over here, taking away these 4, putting them away. So that means that x is equal to 5. And we can represent that algebraically over here by saying that we took away 4 on both sides. 9 minus 4 is 5, and 5 what? Said how many did the friend dump in the bag? We're talking about 5 candy bars. Make sure you label your answer. And that's the idea in this one-step equation. Let's try another problem. Let's take a look at number 2. A friend ate 3 candy bars from the student's bag. The student now has 7 candy bars. How many candy bars did the student start with? So again, see if you can model what this looks like. Take a moment to try that. Otherwise, that's going to look like this. It says, how many candy bars did the student start with? So again, that's what I'm trying to find. That's my x. It says the student ate 3 candy bars. Is that got candy bars or took away candy bars? That would be take away candy bars. That makes it a -3. The student now has, so now means equal, has 7 candy bars. Has means positive, so it equals 7. So algebraically, that would look like this. X minus 3 equals 7. And now our goal is, again, to figure out how much did the student start with. So we need to get just x on this side. So what can I do with this -3 over here? How could I get rid of those -3s? Well, what we can do is we can add 3 on this left-hand side. If I add 3, what that does is it zeroes out that left-hand side, leaving just x. And of course, if we add 3 on the left, we have to add 3 on the right. So we had 7, I added 3 more. That means that our x is equal to 10. Algebraically, that looks like this. We added 3 to both sides. That's what we had to do. Because -3 plus 3 is 0, leaving just x on this left-hand side. 7 plus 3, 7 plus 3 more is equal to 10. So x is 10. 10 what? 10 candy bars. Now let's take a look at number 3. A student started with 11 candy bars and ended the day with 5 candy bars. How many did they sell? Take a moment and set up what you think this equation is going to look like. Otherwise, that's going to look like this. We started with 11 candy bars, so that's a positive 11, so we have 11 ones. They then ended the day with 5. Ended means now, so that's equals. With 5 candy bars, so that's our total. Then ask how many did they sell? Sell, is that positive or negative? That's negative, and we're trying to find how many, we don't know, so that's our negative x. Remember, the question is always what you're trying to find, so in this case, we need a negative x. That's on the left-hand side, because we had 11 candy bars, we sold some, and now we have 5 candy bars. Let's write that equation then. That would look like this. 11 minus x equals 5. Now just take a moment, see if you can figure out what would the x be. Now remember, we don't want negative x, we want a positive x. So how much would that be? Now there's a few ways we can do this. No matter how you do it though, you should end up with the same answer. Now I'm going to show the typical way that would solve most equations, so this would be useful for future reference. But in this particular context, you could do it a couple ways. So I'll show you the way that typically we follow procedurally. My goal is to get the x part by itself. That means all this 11 over here, I want to move to the other side. I'm trying to get just x on this left side. So let's start by just taking away all 11 of these. Or I could think of it as adding negative 11 so that it zeroes out on the left-hand side. We've added a negative 11 on this side, which all zeros those out, leaving just negative x on the left. And again, because I added negative 11 on the left, I need to add negative 11 on the right. We can see that zeroes out those 5s, leaving just negative 6 left. So what we have now is negative x is equal to negative 6. But again, I don't want to have negative x, I want to have positive x. I apologize, there's not one step, there's actually 2 steps. We're going to have to do one more step here. At this point, I can do one of 2 things. As the negative x equals negative 6, I could add x to both sides, making x on this side. But if I did x on the right, I would need to move these negative 6 to the left. So I would add 6 on the left, and on the right, so I'd have positive 6 over here, positive x over here. Instead of doing those extra 2 steps, we can instead divide by a negative 1. When I divide by a negative 1, what that does is it flips the sign. That means that this negative x turns into positive x. And if I flip this left side, I also have to flip this right side since we divided by negative 1. That turns this negative 6 into a positive 6. So algebraically, that looks like this. We technically added a negative 11. That was the operation we did where we added negatives to both sides. Now, adding a negative is just like subtracting a positive 11. Those are equivalent, which is why we don't say plus and negative. We just write minus 11. And we could have done that operation instead. We could have taken away this 11. Over here we don't have 11, but if we add these 0 pairs up here, just add 0 pairs, then you're taking away the yellows, and that left us with red. That's what would have happened. In any case, we get negative x equals negative 6. That's what we had here. From here, we really have how many x's? We have a negative 1x. There's really a 1 in front of this number. So if you don't see a number in front of x, it's implied that it's a 1. If you have a negative 1x equals negative 6, we divide both sides by negative 1. When we divide both sides by negative 1, that flips the sign. And that gives us x equals positive 6. Again, we can see that we flipped these over, and that gave us positive versions of each of those then in this context. And that would be 6 what? 6 candy bars. And like I said, I actually messed up. This is a 2-step equation. Now let's take a look at number 4. An after-school club started with 6 people, but now has 10 people. How many new people joined? Take a moment and decide. Does that look like number 1 or number 2? Go back, look at what we did. Does this look like your number 1 problem or number 2 problem? We'll find that it looks like the first problem. So, let's set up our algebra tiles and algebraic equation. Why don't you take a moment to do that? Otherwise, that's going to look like this. We started with 6 people, so there's our 6. How many new people join? So join is positive, so plus x. Remember, the question is always your x. Now, that's our equals. We have 10. So we have started with 6, we got some more, and now our total is 10. We have 6 ones and an x on the left. We have 10 ones on the right. Now, let's solve that problem. If you haven't done so already, try to solve this now. Otherwise, that'll look like this. Remember, our goal is to get the x by itself, so I need to move these 6 off of the scale. When I move 6 off of the scale over here, then I need to move 6 off of the scale over here. Notice that leaves me with 4. And again, most of us can figure that out pretty quickly, pretty easily, but we're trying to build on this idea that we already know how to do into more complicated ideas. Algebraically, that'll look like this. We took away those 6 from both sides. That left me with x equal to 4. And how many people? So 4 people. Again, that's what you should have been able to do on your own by this point. Again, number 4, if we look at it, was just like we did on number 1. Now let's take a look at number 5. An after-school club lost 3 people due to other engagements. How many people did they start with if they are now at 9 people left? Again, look back. Does this look like number 1 or number 2? I think you'll find it looks like number 2. Try to set this up. It should look very similar to number 2. Otherwise, that'll look like this again. We lost 3 people. That's a negative 3. How many people did they start with? So we start, take away 3, and now equals 9 left, so equals 9. Positive x, negative 3 on the left, 9 positives on the right. If you haven't done this already, try to solve this. As you can tell, this looks like number 2. Try solving it. Otherwise, that's going to look like this. So we added 3 to both sides. This zeroed those out. That leaves us just with the x on the left. And then we had 9. We added 3 more. That's a total of 12. 12 what? How many people? So 12 people. Should have gotten that answer. Now let's take a look at multiplying and take a look at number 6. An after-school club now has tripled the size to 12 people. How many people did they start with? Take a moment. What does that mean to be tripled? If you don't know, look it up. Otherwise, that means this. That means 3 times as many. As many as they started with. We don't know how many we started with. We call that x. To a size of 12 people. With 12, that would be our total. That means we have an equation that looks like this. 3x equals 12. 3x means that we have 3 x's and 12 ones on the right. Now we need to get x by itself. We already have 3 x's. We want to know how much 1 positive x is. So how can we do that? Well, we can divide this into 3 equal groups. So let's do that. So I have these x's. I need to divide these 12 into 3 equal groups. That looks like this. We're literally going to grab them and put them into 1 in each group. As we continue, we'll see how many are left in each, and that'll look like this. We see that once I've divided them into an equal number in each group, that there are how many in 1x? 1x is 4 ones. Algebraically, that's just the idea of dividing 12 by 3, which is how we get x equals 4, and we see how many people, so 4 people is our answer. Again, when you have now x's and you get them separated into equal number in each group, and how many is in one group is your answer. Now let's take a look at number 7. An after school club now has 10 students. 1 month after they started, they doubled in size. How many did they start with? Again, what's our key words here? Now means equals. Our total is has 10 students, that's positive 10. And our other word that we need is doubled. What does doubled mean? That means 2 times as much. Again, what are we trying to find? We're trying to find how many did they start with. That's our x. That's what we don't know. We don't know how many they started with. So we have 2x equals 10. Take a moment now and see if you can set up what does that look like algebraically. Can you solve it? Can you do it algebraically? It should look very similar to what you did on number 6. Otherwise, that should look like this. We have 2x on the left, 10 on the right. Because we don't have any numbers on the left, just the x's. Now we just need to divide it into how many groups? 2. So into 2 equal groups. That'll look like this. We reorganize it into 2 separate groups, and we see that x equals 5. And we're going to say 5 students, because it says they have 10 students, so this would be 5 students. That's how many they started with. Now let's get into solving 2-step problems. Let's take a look at number 8. A coach needs to buy more uniforms. It costs $4 per uniform and $7 in shipping. The total cost was $19. How many uniforms did the coach buy? Just take a moment and see, what do you think that might look like, either with the algebra tiles or algebraically? Otherwise, let's consider what is our total cost here, and what things are contributing to that total cost. Sometimes it helps just to write the words of the things that we're buying. The things that cost us money are $4 per uniform. When it's something per something, this is called a rate. In mathematics, we refer to it as slope. Now technically, slope is just the number, no units. It's something over something, that's slope. When it gets labeled with units, we call that a rate, but we use it interchangeably in mathematics. We'll refer to most of the time as slope, but it's technically a rate. We have our $4 per uniform. How many uniforms did we buy? We don't know. That's our x. Again, the question is what we're trying to find. That's the part we don't know. Because we don't know, we're using this placeholder, a variable, as x. That is going to be multiplied by the cost per uniform, right? Cost per uniform times the number of uniforms, and typically means plus, our $7 in shipping. That's a fee. In mathematics, we call it the y-intercept. It's our starting amount. So our cost per uniform times the number of uniforms plus the fee gives us our total. Total means equal, and our total cost was 19. That's positive 19. So again, equals total cost. So our cost per uniform times the number of uniforms, that together is the cost, plus this one-time fee equals our total cost. Those are all the things you have to pay for. That gives us a total. Why don't you take a moment and just plug in the numbers and or letters for each of these. Shouldn't be too difficult, hopefully. And can you represent the algebraic model? Otherwise, that's going to look like this. So we have 4 x's on the left and 7 ones. That's our 4 times the number of uniforms plus 7 equals our total cost of 19. So this right here is our setup. Now the question is, what do I try to do next? Well, I'm trying to get the x part by itself. So anything that's on the side of the x, I want to move to the other side. So this 7 I need to get rid of. How can I do that? Well, we can simply take away 7. I'm literally just going to move those 7 off of the scale. And if I do that on the left here, I need to take away 7 on the right. Algebraically, we just subtracted 7 from both sides. In doing so, what are we left with? Well, there's 4 x's on the left, and on the right of the equals, we have 12. This is the same exact move we did with the one step, right? I had an x and 7, I just subtracted the 7 from both sides. The only difference is now instead of 1x, there's 4 x's. Now we have 4x equals 12. And like we did with the one step when we had 3x or 2x, here we have 4x. So we're going to divide this into how many groups? 4 groups. Let's reorganize now, and each group has algebraic. All we did was divide both sides by 4 to give us x equals 3. Again, label your answers. 3 what? 3 uniform. Note, we don't label our equation, we only label answers. So this is solving a two-step equation. Probably 95% of the problems you're going to solve, especially in the real world, are going to look like this. Some number x, some number equals some number. We're going to try to find something. Again, it might help to write down in words what our things are. In this case, we had cost of our uniforms times the number of uniforms you had, and that fee that we had to pay for shipping, and that was our total cost. Then once you kind of know the words, maybe you can fill in the numbers and letters. From there, we just did the same things we did on one step. When I had numbers on the side of the x, I subtracted them off. Then I divided my 4 things into equal groups. In this case, since there's 4 x's, divided into 4 equal groups, which has to be the same number in each group. Most of them are going to be, if it's a positive, a plus, you subtract. If it's a multiply, you divide. You're always doing the opposite. If instead of being a positive 7, it had been a negative 7, then we would have added 7. If instead of 4 times x, it had been divide, we would have multiplied. You're always doing the opposite because you're trying to undo the operations. Remember, order of operations says we do 4 times x times that number plus 3 is supposed to give us 19. The issue here is we don't know what that number is. So we're going to go backwards. So if the last thing we did was add 7, so the first thing we do to go backwards is subtract 7. Then we did 4 times x, so to undo times, we divided. Again, probably 95% of the problems you're going to see are going to look something like this. You're either going to add or subtract first. If it's positive, you subtract. If it was a negative, you'd add. And then most of the time, you probably divide. In algebra, if you can handle solving a two-step equation, you're going to go pretty far in this class. The next part is just setting up linear equations, tables, graphs, making that kind of representation from these real-world scenarios. If you can do those 2 things by the time you graduate 8th grade, you're sitting pretty well. The last thing to note here is this equation is a cost equation. That's why it's all positive. Everything is cost. Let's take a look at another two-step problem. Here's number 9. A group is selling boxes of cookies at $3 per box. It costs them $8 in gas and administrative fees to get the boxes. How many boxes of cookies did they sell to make a profit of $19? Try setting up what you think this algebra tile model might look like, or the algebraic representation. Otherwise, that's going to look like this. Here we're trying to make a profit. Profit is found by taking your income, how much money you make, subtracting off your cost, how much you had to pay. Whatever money's left over is called your profit. In this case, the $19 is our total. So we can say that it equals 19. What other parts do we know? We're selling boxes of cookies for $3 per box. Is selling making money or losing money? Since that's making money, that's income. The $3 per box we call a rate. Rate is something per something. Dollars per box, miles per hour, feet per second. All those are something per something. That's a rate. In mathematics, we call this idea slope. Now technically, slope is just a number, no units. When you introduce units of something per something, that's actually a rate. But in mathematics, you'll see it used interchangeably. So this is our slope. It's $3 per box times the number of boxes we sold. Well, we don't know how many boxes we sold. That's what we're trying to find. That's our x. Remember, your question is your variable, your letter. So for income, we have 3x. It's 3 times x because it's 3 times the number of boxes. Again, we don't know how many boxes, but let's say we had 2. That would be 3 times 2. We're doing $6. If we had sold 5 boxes, then be 3 times 5. In this case, it's X boxes because we don't know how many, so it's 3 times X. If you don't see a plus, you don't see a minus, you don't see a divide between the 3 and the X, it's implied that we're multiplying. It means we know anytime I see something, number X, number letter, it's just this number times that letter. If I want to say plus, I have to put a plus in between. If I want to subtract, I put a minus in between. If I want to divide, I'd have 3 over X, like a fraction. So 3X means multiply. Now we're going to subtract off our costs. What was our cost? It says that it cost us $8 in gas and administrative fees. So that's a cost. That's something you have to pay. That's why we're going to subtract that off from our income. So 3 times the number of boxes I sold, take away the $8 I had to pay, gave me this total profit of $19. That's how much money I left over after I paid my costs. So we have 3x minus 8 equals 19. Take a moment and set up that algebra tile model. What would that look like on the left? Why does that look like this? So on the left we have 3 x's and negative 8 of the ones. On the right we have 19 positive ones. Now, like before, what's my goal? My goal is to get the x part by itself. That means I need to get rid of this negative 8 on the left. How can I get rid of this negative 8? I could subtract negative 8, right? Take away the negative 8, but notice there's no negatives over here. I could either make some 0 pairs, or I could just make this side, this negative 8, 0 by adding 8 on both sides. So I added 8 on the left, that zeroed out those negative 8, leaving just 3 x's on the left. On the right, I also had the 19, and then I've added 8 more, for a total of 27. Algebraically, we added 8 to both sides, giving us 3x equals 27. Notice, if we had 1x minus 8, we would have added 8 to both sides. Same thing we did for one step, we're doing now. The only difference is now we have 3 x's instead of 1x. Now that we have 3x equals 27, remember, how do I figure out just what 1x is? I have to divide that into 3 groups since there's 3 x's. That means over here I need 3 equal number groups. That becomes this. We've now divided these x's into 3 equal groups, which means then that x is equal to 9. Algebraically, we just divided both sides by 3, giving us x equals 9. And that would be 9 boxes of cookies. Oh, the other thing I forgot. So slope is your dollars per box. This cost of $8 in gas, that's your fee. In mathematics, we call this the y-intercept. The y-intercept is your starting amount. You pay $8 no matter what. Even if you don't sell any cookies, you'd have to pay $8. That's that starting amount. You're starting $8 below making money. Then we make money by selling boxes at $3 per box. Those two things together is our total profit. And you'll find a lot of things look like this. It's some number x, some number equals some number. A lot of this is called linear. And you'll see that all the time in real world problems. The reason that we had minus 8 instead of plus 8, unlike number 8, is that this isn't all cost. In this case, we're talking about profit. I have some income, some stuff I make money, some stuff I lose money. So that's why it was the positive and negative. And number 8, that was all cost. So we can think about it positively because it's a cost equation. But this is a profit equation. So when you have income and cost, that's when you have to consider the positive and negative. Again, intuitively, a lot of us can figure out that we sold 9 boxes. What we're trying to get to, though, is being able to represent this and solve algebraically so that we can do more complicated problems and communicate that idea with others. And the last little thing I want to say is this. Notice that these few sentences is really boiled down to just 1, 2, 3, 4, 5 things. 3x minus 8 equals 19. this entire paragraph here is represented with just 5 things. Simplified, represented that way. So this is a really neat way of making this big old thing into just 1, 2, 3, 4, 5 things. It's actually just technically called 3 terms. Now let's take a look at number 10. A family of 6 go to a pool. They spent $11 on food. If the total cost is $23, how much should it cost per person to get in? Take a moment, see if you can set up that equation. Ask yourself, does this look like number 8? Is this going to be a cost equation? Or does this look like number 9? Going to be a profit equation? We see that we're finding the total cost was 23. So we're making a cost equation here. So it's going to be like number 8. With that in mind, can you set up what you think this is going to look like? Otherwise, that's going to look like this. We have how much should it cost per person? That's our X. Remember, cost per person. Really, in this problem, we're actually finding the slope here. So before we told you the slope, and this one we're trying to find the slope. But we also know that we're going to have 6 people go to the pool. So we have our cost per person times the number of people. Is there any other costs we have? Yeah, we have our cost of our food. The cost of our food is our y-intercept idea. Right, that cost is constant. It's $11, no matter what. What does change is this part. We don't know this part, so that's the part that changes. We have a total cost of 23, so the cost per person times the number of people together plus food equals our total cost. Take a moment and see if you can plug in the numbers or letters into these parts here of these words. Again, if you can write down the words, it'll be really easy, hopefully, to plug in the numbers. What does that equation look like? Well, we get x times 6 plus 11 equals 23. We don't ever write letter then number. We always write the number then the letter. So we're actually going to rewrite this as 6x plus 11 equals 23. We always write the number then the letter. Take a moment, set that up as an algebra tile model. What is that going to look like? Should look like this. We have 6 x's on the left and 11 ones. On the right we have 23. If you haven't done so already, try to solve this now. Same thing we did before. Remember, the goal is to get the x part by itself. And you need to get rid of these positive 11. What can you do? And how can I get just x? How many is just one positive x? That's always the goal you're trying to do when you're solving your algebra. Take a moment and solve that. Otherwise, that should look like this. We're going to take this 11 off of this side, subtract 11. We have to do the same thing on the other side. Take away from 11 from that side. In doing so, we subtract 11 from both sides algebraically, leaving us with 6x on the left, and on the right, we have 12. Now we need to make this 12 into 6 groups. So an equal number in each group. How many would be in each group? We see that that would be, we get 2 in each group. Algebraically, we divided both sides by 6. We divided by 6 because we divided by the number in front of x. Remember, 6x means 6 times x. So to undo times, we divide. We're trying to get how much is 1x, right? So 6 divided by 6 is 1. Still the x. So we just write x. We don't write the 1 in front of x. That's redundant. If it's x, we know it's just 1x. So if there's more than 1x, that's when we put a number in front of x. So if x equals 2. And 2 what? Well, it says cost per person. So cost here, we're talking about dollars. So this is the $2 per person. You'll see this slash is something we use that means per. $2 per person. Now let's look at combining like terms. We'll start with number 11. At a grocery store, Lee bought 2 bags of chips and also spent $8. The next day, Lee bought 3 more bags of chips. Between the 2 days, Lee spent $23. How much does a bag of chips cost? See if you can represent that with the algebra tiles or an algebra equation. Take a moment, try that. And again, one of the ways we can think about this is just write down what do we know. we have 2 days of buying food. Day 1 and day 2 equals our total. Right, that's what we know. He spent some money on day 1, he spent some money on the second day, and now together, that's the total. How much did he spend on the first day? Well, it says he bought 2 bags of chips and $8. Notice that the bag of chips, though, isn't a cost. How much does a bag of chips cost? We don't know. It says how much does a bag of chips cost. That's what we're trying to find. That's our X. That's a cost per bag. Again, what we're finding here is the slope. So just like we were finding slope in the previous problem of finding what the cost was per person to go to the pool, we're finding the same idea. This is the cost per bag of chips. So day 1 is really number of bag of chips times the cost per chip plus our other costs for the day, and that's all day 1. The next day, so day 2, he bought 3 more bags of chips. Is that going to be like the blues or the yellow? It's going to be like the blues. All of these together equal our total. Our total spent between the 2 days is $23. Take a moment and plug in the parts that we know, then see if you can set up this algebra equation. Otherwise, it's going to look like this. We have our 2x plus 8, right? 2 bags of chips times the number of chips plus $8. This is all day 1. Plus about 3 more bags of chips. That's 3 times x, because again, we don't know what that cost is. This whole thing is equal to 23. Again, we're making a cost equation here. That's why the whole thing's positive, because it's all how much we spent. Take a moment then and model this with algebra tiles. What would that look like on the left and right? Well, that should look like this. So on the left we have the 2x plus 8, and then we got 3 more x's, and on the right we have 23. So now what should we do? Take a moment, think about what we might do here. So what we typically want to do is we want to put our x's together. So the 2x and 3x together is 5x. And then we still have the 8 on the left and the 23 on the right. So algebraically, all we've done is put the 2x and the 3x together. They're both on the same side. We just said, hey, I know there's 2x and there's 3x, but really, let's just say there's 5x. So we're going to say there's 5x still plus 8 equal to 23. Notice now we're just solving a 2-step equation. We already know how to do that. The same thing we just did with solving 2-step equations. So take a moment, try to solve that. Otherwise, we're going to see it look like this. We'll start by subtracting off the 8 from both sides. So I moved that 8 off of the scale on the left, moved 8 off of the scale on the right. We see that we're left with, on the left-hand side, 5x. And on the right, we have 15. Like before then, I have 5x equals 15. I need to figure out how much one set of x's. So I need to divide these x's into 5 groups because there's 5 x's. And that means this 15 gets rearranged to be 3 in each group. I just rearrange those 15 into the same amount in each group. And we see that 1x then would be 3. 3 what? It's cost of our bag of chips. So this would be $3 per bag of chips. So this is the idea of combining like terms. You might end up with extra parts that you want to put together on the same side. In this case, we had x's that need to go together. Sometimes you have numbers that go together. Sometimes you have both x's and numbers that need to go together. But you're putting everything on the one side together, then you start solving by doing the inverse operations. Now let's take a look at this problem. A farmer buys chickens for $3 per chicken and pays $7 they owed to the other farmer. The farmer also paid $6 to another farmer they owed and bought some more chickens at $2 per chicken. How many chickens did the farmer buy if the total money they spent was $33? Take a moment and see what you think that might look like, either the algebra tiles or the equation. Otherwise, let's consider this. We have farmer 1 and farmer 2, and together is our total. How much did they spend with farmer 1? We pay $3 per chicken and $7. Again, we're spending all of this. This is our total spent, which means we're writing a cost equation. So the $3 per chicken and $7 owed is all part of the farmer one. The $3 per chicken is our slope. The $7 is our y-intercept. How many chickens did we buy is our x. Try to write the expression for farmer 1. What would that look like? It would look like this. We have 3x plus 7. $3 per chicken. How many chickens did you buy? We don't know. If it was 5, it'd be 3 times 5. If it was 17, it'd be 3 times 17. If they bought 20 chickens, 3 times 20 plus the 7. Again, all of this is positive because it's all cost. If you wanted to do everything negative, you could, right? Negative 3x minus 7, everything's negative, including my total is negative. But all of those end up canceling out when we divide by -1 at the end, so this is why it's easier just to write it all in positive terms. And talking about all of this is our total positive cost, how much I'm gonna pay. What do you think farmer 2's total is gonna look like? Again, it should look very similar to this in this context. Take a moment, try that. Otherwise, we're gonna have pays another farmer $6 and $2 per chicken for there. Which of these would be the slope, the 6 or the 2? Again, look at what we wrote on the first one. Which of these is going to be the slope? That's going to be the $2 per chicken. That makes the $6 the y-intercept. You'll see that abbreviated is this y-int. That's the y-intercept. Again, the y-intercept's my starting amount. Whether the farmer buys chickens or not, the farmer has to pay $6, no matter what. That's the starting amount the farmer has to pay. Then it's extra for every chicken he buys is another $2. What would that look like then for the farmer 2 part? That would look like this. We get 2x plus 6. Again, 2 is my slope. That's the number with the x. Plus it's $6. That's starting amount, right? That doesn't change. It's always $6 for farmer 2. That equals my total. What's my total? We get equals $33. See if you can model what that looks like then with the algebra tiles. That would look like this. So we have 3 x's and 7 1's. Also we have 2 x's and 6 1's. And on the right hand side we have 33 1's. Like before, it's easier to put stuff together. It just makes it easier to count. So what should I do? I should put my x's together and I should put my 1's together on this left hand side. On the right hand side, there's nothing to put together, it's all just 1's. So we're only going to put together the stuff on the left. And that means we have reorganized this into 5x and 13 1's on the left instead of the 33 on the right. So we have 5x plus 13 equals 33. Again, now all we're doing is solving a 2-step equation. We know how to solve that. Do that if you haven't done so already. Otherwise, we know it's going to look like this in the end. We started by subtracting the 13 off of the left and took 13 off of the right to give me 5x is equal to 20. That 20 then I rearranged into an equal number of groups. There's 5 x's, so I had to make 5 groups. We see that in one group then there are 4. That means that the farmer bought 4 chickens. You can verify that's correct by plugging in 4 in place of x. 3 times 4 is 12, plus 7 is 19. 2 times 4 is 8, plus 6 is 14. So 19 plus 14, and we see that is indeed $33 in total. And it's even more obvious on this, right? We spent $5 per chicken in total, times 4 chickens, that's $20, plus the $13 that we owed the 2 farmers. Paid $33 in total. Let's see if we can solve this next problem. A parent on their way home stops to buy dog food at $3 per bag and picks up some other stuff for another $5. They continue on their way, but then their spouse calls and asks them to pick up more stuff. At the next store, they buy more dog food, this time at $2 per bag, and spend another $6. The total between the two stores is $31. How many bags of dog food did the parent end up buying? Take a moment and try to set this equation up, or do the algebra tile model. See what this looks like. Otherwise, our setup's going to look like this. We have $3 per bag of dog food, and we don't know how many dog foods there are. That's our x, so it's 3x. And typically means add our 5. So we have 3x plus 5. Again, the $3 per bag, that's our slope. The $5 is our y-intercept. And we pay $5 no matter what, regardless of how many bags of dog food we buy. Those together is the first store. This next store, the plus, we have $2 per bag of dog food and another $6. Again, and plus 6. So 3x plus 5 plus 2x plus 6 together is our total, which equals 31. On the left-hand side then of our algebra tiles, we have 3 x's and 5 1's, followed by 2 x's and 6 1's. On the right-hand side, we have 31. Now, see if you can solve this. It's just like we've done in the previous ones. Otherwise, that'll look like this when we're all said and done. So we put our x's together. We had 3 x's and 2 x's. That's 5 x's. Then we had the 5 1's and the 6 1's. That's a total of 11. I took 11 off on the left, and then I took 11 off from the right. So 31 minus 11 gave me 20. We then had the 5 x's equal 20. I rearranged those 20 into equal groups. And we see here then that one group is 4. That means that they bought 4 bags of dog food. Again, when combining like terms, you're putting stuff that's the same together on the same side. And then once we get down to this two-step equation, we know how to solve that. Now let's look at the idea of distributive property. In this problem, a group of 4 friends plans on buying sandwiches at a fast food place. The one friend is going to get the sandwiches and chips and pop. Remember that the sandwich by itself is $3, but can't remember what it cost to have the meal with the chips and pop. After returning, the friend forgot to grab the receipt, so they're not sure how much the chips and pop were. If the total bill was $16, how much did the chips and pop cost? Why don't you just take a moment and see if you can figure it out. Don't even worry about making an equation or algebra tiles. Just can you figure out what this answer would be? This might be a scenario that you run into. Here's how we could solve that. When we're trying to write an equation, start with just writing down the things we know. What do we know? Well, we have 4 friends. We also see that the one friend buys all of the meals for the 4 of them. They know that $3 is a sandwich, but they don't know how much the chips and pop cost. They do know that the total bill was $16. So what do we have? Well, we have 4 friends, and each of them buy sandwich and chips and a pop. That one friend paid for everything, but really it's 4 orders of the same thing for a total of that. Take a moment, plug in the parts we know. So the 4 friends we can call 4. That's being multiplied, so by the quantity, that's this parenthesis part. The sandwich was $3 plus the chips and pop, we don't know how much it is, so we're going to call that X. That gave us a total then of $16. So again, intuitively, you might already know the answer of how much the chips and pop are. But we're trying to set this up so we can do more complicated problems later. So read this as 4 times the quantity, that's this parenthesis part, 3 plus X. So we say 4 times the quantity, 3 plus X, equals 16. So pause lets you know when you stop. Can you solve this problem? What would you do? Let's start by setting up the algebra tile model. So here's one order. We have 3 plus x, that's one order, but I need 4 of those, so now we have 1, 2, 3, 4 orders of that. And on the right hand, we need 16. Now what should we do? Well, if you look on this left, this is just like when we were combining like terms, right? I wanted to put my x's together and I want to put my numbers together. Let's do that again. So rearranging, we saw that we had 1, 2, 3, 4 x's, and 3, 6, 9, 12 ones. Over here, algebraically, what did we do? Well, we said we had 4 times this group, this 3 plus x. What we did is we did 4 times 3 and 4 times x, which gave us 12 plus 4x equals 16. Notice that by multiplying this number to every single term inside the parentheses, we've now gotten rid of our parenthesis. Now that I don't have a parenthesis, I can move stuff around. The initial problem here was we had 3 plus x. You have to do that first, then multiply by 4, right? That's what parentheses tells us. So I can't move anything inside this parenthesis until I get rid of it. So by multiplying through, we get rid of that parenthesis. We now know how to solve this two-step equation. 12 plus 4x equals 16. Take a moment, try to solve that. Otherwise, we're going to have. So we subtracted off the 12. We here subtract off the 12. That left me with 4 x's. And 16 minus 12 left me with 4. We then divided them into equal groups, right? There are 4 x's, so divided into 4 groups. That means that one group of x's is 1. So the chips and pop together is $1. Which makes sense. 3 plus 1 would be 4. 4 times 4 is indeed 16, so we know we're correct. This is the idea of distributing. It comes about when we have to get rid of this parenthesis, right? When I have something happening a certain number of times, this number of groups is happening this number of times, we can't move anything inside the parentheses until we get rid of it. One of the ways we can do that is multiplying that number to each term inside the parentheses. Once we don't have the parentheses, then we can solve our problem. Again, you may have to combine terms first. In this case, we didn't. This is ones, right? And this is x's. But there are certain scenarios where you might have ones and x's and more ones and more x's even after you distribute. So make sure you want to simplify your left side first, simplify your right side first. Try to get down to like some number and a number x, maybe a 1 or both sides that happens. And then you're trying to get x's on one side, numbers on the other side, and figure out how much one positive x is. That's the idea of solving an algebra problem. Why don't you try this next problem? 2 teams are working together to build a robot. The first team can make 4 robots in a month. The other team creates a robot each month as well. After 3 months, the total number of robots created was 27. How many robots did Team 2 make each month? Again, try to set this up. It'll be a similar kind of look to what you just saw. What do you think that's going to be? Again, start by figuring out what you know. We know that the first team can make 4 robots in a month. And we have a second team, but we don't know how many robots the second team makes each month. Again, the thing I don't know, we call that x. So 4 plus x is how many robots is made each month between Team 1 and Team 2. They make that for 3 months. And our total then is 27. So we have 3 times the quantity of 4 plus x equals 27. Again, 4 is how much the first team can make in 1 month, plus x. We don't know how many Team 2 makes in a month, but that's how much they make in a month is x. So 4 plus x is how much they make in a month, times 3 months gives me a total of 27. So how much does Team 2 make? See if you can set up that with the algebra tile model and try to solve it like we did in the last one. Otherwise, we should have something that looks like this. So we have 1, 2, 3, 4 robots that the first team makes, plus the second team, which is X. There's 1 month, 2 months, 3 months of that. And 27 on the right. And now, let's rearrange the left-hand side, right? Combine like terms. We see then on the right, I would have to distribute. Take a moment, try to do those, see what you get. Rearranging, we had 3x plus 12, or 12 plus 3x, equaled 27. Again, you know how to solve that. Take a moment, try to solve that. Otherwise, we know it should end up like this. So, we subtracted 12 from both sides, giving us 3x equaled 15. We then divided that 3x into 3 separate equal groups, and we see that one group is 5. That means that there are 5 robots each month for Team 2. That's how many they make. Now let's look at variables on both sides. Maria picks apples each day. She already has 5 apples and picks 2 apples per minute. Her best friend Jessica just started picking apples with Maria. Jessica picks 3 apples per minute and already has 1 apple. How many minutes will it take for Maria and Jessica to have the same number of apples? See if you can figure that out. Again, start with what you know. What are we trying to do? Well, we want to find out when Maria and Jessica are the same. We see that Maria has 5 apples and picks 2 apples per minute. Which of those is the slope and which of those is the y-intercept? The 5 and the 2, which one's slope, y-intercept? The 2 apples per minute is called our slope. And the has 5 apples part is our y-intercept, which you'll see abbreviated as y-int. So that's Maria. And of course our variable is how many minutes will it take them. So x is our minutes. Try setting up what it would look like then for the Maria side. 2 apples per minute times the number of minutes, and our apples, what would that look like? We should have 2x plus 5. We want that to be equal to Jessica's. Because we want to find when these two are the same. Remember, same means equal. We see that Jessica picks 3 apples per minute and already has 1 apple. Again, which of those is the slope and which of those is the y-intercept? Is the 3 the slope or is the 1 the slope? Try setting up what you think Jessica's going to look like. Otherwise, you should have 3x plus 1. We have 3 apples per minute times the number of minutes plus the apple she already had would be how much Jessica's done. Now this problem is actually what we call a system problem. Notice that we have x's on both sides and we have numbers on both sides. Why don't you take a moment and just set up what that algebra tile model would look like. We have 2x plus 5 on the left. We have 3x's plus 1 on the right. Now, let's see if you can solve this problem. Remember, ask yourself, what's our goal? Our goal here is to get all the x's on one side, all the numbers on the other side, to find out how much one positive x is equal to, what equals what number. See if you can do that. Otherwise, we're going to have something like this. Let's start by taking away our 2x on the left. And again, if I take away 2x on the left, I have to take away 2x's on the right. So algebraically, we subtracted 2x on both sides. This left us those 5 ones on the left, an x and a 1 on the right. So 5 equals x plus 1. Again, I want to have just x, not x plus 1, so what should I do with this 1? Okay, let's try that. We then took away the 1 from both sides, and we see that x is equal to 4. Or you might say 4 is equal to x. Again, what does x stand for? This would be 4 minutes. This is how long it would take Maria and Jessica to have the same amount of apples. If I had asked you how many apples that would be, you would just do 4 in place of the x. So 2 times 4 is 8, plus 5 is 13. That means that Maria would have 13, and Jessica should also have 13 when I plug in 4. Double check. 3 times 4 is 12, plus 1 is 13. So this means they both would have 13 apples after 4 minutes, or at 4 minutes. Now another thing to note is typically when you get your x's on the same side, it's usually not 1x. Right? Usually it's more than that. So what you typically would get down to is a number equals number x. You would have to divide both sides by that number in front of x usually. In this case, we already had just 1x, so we didn't have to do any extra work. But typically, by this point, you have like 5x or something, or 7x or something, and you have to divide both sides by that 7. I have a sense that you might run into a problem like that in your immediate future. Let's try solving this problem. Maria's gotten better and now picks 5 apples per minute. If Maria already has 3 apples in her bag, how long will it take her other friend Lisa to have the same number of apples in her bag if Lisa picks 3 apples per minute but already has 7 apples? See if you can set up that equation or set up that Algebra model, or even just try to find the answer any way you want. See what you can come up with. Otherwise, again, just start by writing down the things you know or what you're trying to do. We again want to find when Maria is equal to Lisa in this case. What do we know about Maria? Well, Maria can pick 5 apples per minute. Is that idea a slope or a y-intercept? That idea is a slope. Maria already has 3 apples. That idea is our y-intercept. How long will it take is again our x. So what would Maria's equation side look like? Well, that would be 5x plus 3. Right? It's 5 apples per minute times the number of minutes plus the 3 apples she has is how much in total Maria has. We need that to be the same, which we know means equal, as Lisa. We know that Lisa can pick 3 apples per minute. Is that 3 apples per minute, again, the slope or the y-intercept? You see that that's the slope. Again, typically when you have something per something, in this case apples per minute, or miles per hour, feet per second, those are all rates. Rates are slope. Lisa already has 7 apples. Again, that's that starting amount. She starts with 7. That starting amount we call the y-intercept. We abbreviate the y-intercept, like we did up here, as y-int. So, write Lisa's equation side. We get 3x plus 7. So Maria is 5x plus 3. Lisa is 3x plus 7. We want to find when those two are the same number of apples in their bag. Try to set up the algebra tile model. We have 5 x's and 3 1's is equal to 3 x's and 7 1's. Now we've set up our equation. Can you solve it? Let's try it. Literally pause the video and see if you can get the answer. Alright, that's going to look like this. Again, we ask ourselves, what's our goal? Our goal is to get the x by itself. That means all the x's to one side, all the numbers to the other side. So I want to take away this 3x on this right-hand side. And if I take away 3x on the right-hand side, I need to take away 3x on the left-hand side. Algebraically then, we've subtracted 3x on both sides. This leaves us with 2x's on the left. Now, at the same time, we can also get rid of these 3 1's on the left, which means I also have to get rid of 3 1's on the right. Algebraically then, we've subtracted 3 from both sides. Notice what we've done. We've subtracted x on one side, and we've subtracted numbers on the other side. We should zero out the numbers on one side and an x on the other side. Doesn't really matter which way you do it, but I would suggest moving the smaller x to the other side. That keeps it a positive x. Again, since I moved the x's from the right over to the left, I need to move my numbers from the left over to the right. We end up with 2x equals 4. 2x equals 4. Now we're just dividing these 2x into two equal groups. They're pretty much already there, and we see that dividing both sides by 2 means that x equals 2. And that would be 2 minutes. And we can abbreviate minutes by writing MIN. So this says that it would only take 2 minutes for Maria and Lisa to have the same amount of apples in the bag. We can double check. 5 times 2 plus 3 is 13. 3 times 2 is 6, plus 7 is 13. 13 does equal 13, so that's when they would have the same amount. Both would have 13 apples, in this case again, in 2 minutes. And this is how we handle variables on both sides. You want to get all your x's on one side, you want to get all your numbers on the other side, then typically we'll divide both sides of that number in front of x. Again, we get that to the other side by doing the opposite sign. If it's a positive, we subtract. If they had been a negative, we would have added. Get number x equals number, divided by the number in front of x. Boom, there's your answer. Last thing to note is I subtracted 3x from both sides. I could have written 2x plus 3 equals 4 in order to solve that algebra equation, or you can do them at the same time. Notice on both of them, I subtracted 3x minus 3 on both sides. Because I did exactly the same thing on both sides, I kept it equal. That's why I could do that. But if you want to take it in 2 steps, you can. I'll show you what that looks like down below. So here, I subtracted 3x from both sides, got 2x plus 3 equals 7. Again, now you're just solving a 2-step equation, which we subtract the 3 from both sides like we did, giving us 2x equals 4, and then dividing both sides by 2 to get x equals 2. Again, whether you do that in 2 steps or do it all in 1 step, you should still get x equals 2. And that's how we handle variables on both sides.